we're going to be talking about multiplication properties of exponents. And we're going to start with something called the product of powers property. If a is any non-zero real number and m and n are integers, then a to the m times a to the n equals a to the m plus n. In other words, if the base is the same, you just add the exponents together. So let's take a look at this. We have 7 to the 8th times 7 to the 4th. You're just going to say, since the bases are the same, they're both 7, 7 to the 8 plus 4, which gives you 7 to the 12th. Okay? Next, if we have 3 to the negative 3rd power times 5 to the 8th times 3 to the 4th times 5 to the 2nd. Take the bases that are the same. So we have we have two of them with 3. So we're going to take 3, and the exponents on those are negative 3 and 4, so we're just going to add them together. On the 5s, the exponents are 8 and 2, so we're going to add those together. And so we get 3 to the 1st times 5 to the 10th power. Let me erase that. So in other words, you can just write that as 3 times 5 to the 10th. You can leave the 1 as an exponent if you wish, but you don't have to. Okay, let's say we have this next one, m times n to the negative 4, m to the positive 4. I would actually write in the exponent of 1 on m, because even though it's not listed there, that's what it is, m to the 1st. So add together the exponents on the m's, and we get 1 plus 4 is 5, m to the 5th. And then we have n to the negative 4th power. Since we have a negative exponent, as you recall, we're going to have to move that to the denominator to make it positive. So n to the 4th goes down below to the denominator, and we end up with m to the 5th over n to the positive 4, because that exponent now becomes positive in the denominator. Next, let's say we have x times x to the negative 1 times x to the negative 3rd times x to the negative 4. X is the same as having x to the 1st, so let's just write that in. And we're just going to add all of those exponents together. 1 plus negative 1 plus negative 3 plus negative 4. And we get x to the negative 7th power. Well, it's got a negative exponent, so we can't keep it. We have to change it. So we're going to move x to the negative 7 to the denominator, where the exponent becomes positive, and we have 1 over x to the 7th. Next, 3 to the 2nd times 3 to the 5th. Add your exponents together, so we have 3 to the 7th. Next, 2 to the 4th times 3 to the 4th times 2 to the negative 2 times 3 to the 2nd. Add together the exponents on the 2. So we have 4 plus negative 2 right here. 4 plus negative 2 gives you positive 2, so we have 2 to the positive 2. On the 3's, 4 plus 2 gives us 6, so we have times 3 to the 6th. Next, q to the 3rd times r to the 2nd times q to the 6th. Add together the exponents on the q's, so we have q to the 9th power, and then we have just r squared, because there's no other r involved in this particular problem, so we just have to keep the one we have. This next one, n to the 3rd times n to the negative 4 times n. There's an exponent of 1 on the n, so we're going to add together the exponents, and if we add 3 plus negative 4 plus 1, we end up with n to the 0 power, and anything raised to the 0 power is 1. So our answer automatically turns into 1. Now let's move on. We're going to go on to our next page. We're going to talk about the power of a power property. So if you have something like a to the m and you raise it to the nth power, in other words, if there are parentheses between the m and the n, you multiply those exponents together. So it's a to the m times n. So 5 to the 2nd raised to the 4th power. That's 5 to the 2 times 4. or in other words, 5 to the 8th. Moving on, 4 to the 3rd raised to the 0 power. It's 4 to the 3 times 0, or in other words, 4 to the 0, which is just 1. Anything raised to the 0 power is 1. X to the 3rd raised to the negative 5 power. X to the 3 times negative 5 gives you negative 15. You cannot leave your answer with a negative exponent. Make your fraction bar. So we're going to move x to the negative 15 to the denominator where it becomes x to the positive 15. And we have 1 over x to the 15th. Continuing on, 3 to the 4th raised to the 5th power. We have 3 to the 4 times 5, so that gives you 3 to the 20th power. 6 to the 0 raised to the 3rd power. 0 times 3 is 0, so we have 6 to the 0. Anything raised to the 0 power is 1. The last problem in this particular section, we have two particular pieces that are raised to a power. So we have a to the 3rd raised to the 4th. Well, a to the 3 times 4 is a to the 12th. We have a to the negative 2 raised to the negative 3rd power. And you're probably thinking right now, oh, I got to move things to the denominator. But no, you don't, because negative 2 times negative 3 gives you positive 6, which is great. Now we have a problem similar to what we were doing on our previous page. We have a to the 12th times a to the 6th. Both bases are the same. They're both a's, so we are just going to add those exponents together. A to the 12 plus 6 gives us a to the 18th. Okay, so now moving on. Power of product property. So if a and b are any non-zero real numbers and n is any integer, then a to the b in parentheses, then a times b in parentheses raised to the n power is equal to a to the n times b to the n. In other words, you raise everything inside your parentheses to that power on the outside. So for example, if we have 4p in parentheses raised to the 3rd power, that means you're going to say 4 to the 3rd power times p to the 3rd power. And you can simplify that a little more. 4 to the 3rd power is 64. So we have 64p to the 3rd. Next, if we have negative 5t squared in parentheses raised to the 2nd power, that means you have negative 5 in parentheses to the 2nd power times t to the 2nd raised to the 2nd power. Okay, kind of clever here. Negative 5 to the 2nd is positive 25. Negative 5 times negative 5. T to the 2nd raised to the 2nd power, that's just t to the 4th. And you could have actually multiplied those exponents together earlier if you had wanted to. That would have been fine. Actually, let's do that on this problem. We have x to the 2nd, y to the 3rd raised to the 4th power. That's the first part of this problem. So what we're going to do is multiply our exponents together. In other words, 4 times 2, kind of looks a little bit like the distributive property, 4 times 3. So we have x to the 8th, y to the 12th. Now, doing the same thing with the next piece here, x to the 2nd, y to the 4th, raised to the negative 4 power, x to the 2nd, raised to the negative 4th, 2 times negative 4 gives you negative 8. Y to the 4th raised to the negative 4 power. Negative 4 times 4 is negative 16. So now, if we go to if we go and look at the similar bases, the like bases, we can add exponents together. So we have x to the 8 plus negative 8, and you've got y to the 12th plus negative 16 on the y's. Now, x to the 8 plus negative 8 just gives you x to the 0. 12 plus negative 16 gives you negative 4. So we have x to the 0, y to the negative 4. Let's move it up here. X to the 0 is just 1. Anything raised to the 0 power is 1. So we've got 1y to the negative 4. You can't leave your answer with a negative exponent, so let's move y to the negative 4 to the denominator, and we end up with 1 over y to the positive 4. Okay, let's continue. We have negative, and then parentheses, 2y to the second. So that means we're just going to drag our negative along since it's not in the parentheses. We're going to have 2 to the second, y to the second. Raise everything inside to that second power. So we have negative 4y to the second when we simplify it. Remember, you're just dragging that negative along. Now next here, the negative is in parentheses. So you're going to take negative 2 in parentheses to the third power times y to the third power. Negative 2 to the third, negative 2 times negative 2 times negative 2 is going to give you negative 8 followed by y to the third. Last problem. We have x to the sixth times y to the negative third power all raised to the second power. So we're going to multiply each of the exponents inside the parentheses by the 2 on the outside. So we're going to have x to the 12th, y to the negative 6. You can't leave that negative exponent in your answer, so we're going to draw a fraction bar, keep the x to the 12th where it is because the exponent's positive, move y to the negative 6 to the denominator, so it becomes x to the 12th over y to the positive 6. And that is it for today. Thank you for joining me.